Okay, so welcome back to the second part of statistics for sample space. Alright, so in the last lesson, we completed the first two, which is list and greets and Venn diagram. So today we will complete the tree diagram and two-way table. So today's one will be a rather short class because these two is not as much as the Venn diagram. Okay, alright, so let's go back to your manual now. Okay, tree diagram, you have done this in school before. There's just a little bit different now. You have to follow the rules here. Okay, so you will have the branches. This is what a tree diagram is. It follows the sequence of the event. Okay, so the two branches, this one is when you toss the coin. See, when you toss the coin, what's the possible outcomes that you get? Head or tail, right? So what's the probability you get head? 0.5. What's the probability you get tail? 0.5. Okay, so you must write your probability on the branch and the outcome at the end. It must be in this format. You don't go and write it in any other way. All right, okay, so there are two branches. One is head, one is tail. The probability of each branch is written on the branch here. This is what it means. The outcome is written at the end. So why is it 0.5? Because it's a half and half chance when you toss the coin. Okay, so this is when you do it once. What if I do it twice? So it will branch out. So the first one, head, tail, 0.5, 0.5. This is the second toss. So if I get a head, what's the probability of getting a head again? 0.5. Branch out here, tail, 0.5. You get a tail, what's the probability of getting a head? 0.5, 0.5. So can you see that? The only thing that is compulsory now, you have to write down your outcome. You don't need to write it in full. You can just write HH, HT, TH, TT is fine. Okay? All right? Okay, so let's take a look at this. This is what we were doing just now. Then you need to write down the probabilities. What's the probability of getting a head and a head? The word here is and. That's why you multiply 0.5 times 0.5. This way is always multiply. Downwards is always add. Understand? What's the probability of getting head and tail? Head, tail, 0.5 times 0.5, 0.25. So you will multiply, put it here. In order for you to check if your tree diagram is correct, you have to total up. This must be 1. If you total up, this is not 1, then you know you have made a mistake. So when it comes to tree diagram, right, it's very easy to basically get it right. Because when you total, it must be 1. If you don't get 1, then you pretty much know you are wrong somewhere. Okay? Okay, what's the probability of getting a head and a head? So what's the probability of getting a head and a head? 0.5 times 0.5, 0.25. What is the probability of getting at least one head? What does it mean by at least one head? Either two heads, that means either head, 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 tail, tail, head. So meaning these three you add up. Or whenever you see at least one, you can 1 minus the opposite. That means 1 minus no head at all, which is 0.25. You will get the answer. All right. So now there are two types of tree diagram. One is with replacement and one is without replacement. In other words, with replacement is an independent event. Okay, in a box there are 7 colored balls, 2 blue and 5 red. One ball is removed, the color is noted, then returned. So what does that tell you? You take it out and then you put it back. So when you take it out and put it back, the number of balls in the box still remain as 7. It doesn't change. Okay, it doesn't change at all. That tells you that this is an independent event. The first event hasn't affected the second event. First event also got 7 balls, second event also got 7 balls. So you must read the question. The question is very clear actually. They already tell you whether they return it back or not. Okay, with replacement or not. So the first one, what's the probability of getting a blue ball? 2 over 7. 2 out of 7. What's the probability of getting a red ball? 5 out of 7. Then you branch out again. 2 over 7, 5 over 7. Because the probability will be the same, it won't change. Because it is independent, it is the same. Okay, then you write down your outcomes, BB, BR, RB, RR. You don't want to write the N in between also is fine. How to find black and black? What's the probability you get black and black? 2 over 7 times 2 over 7, 4 over 49. What's the probability you get black and red? 2 over 7 times 5 over 7, 10 over 49. What's the probability you get red and black? 5 over 7 times 2 over 7, 10 over 49. What's the probability you get red and red? 5 over 7 times 5 over 7, 25 over 49. So you total up this, you must get 1, which is 49 over 49. Then you know you're pretty much right. So which is the most likely outcome? When you see most likely outcome, you're always looking for the one with the highest probability. So in this case, what is the most likely outcome? Red and red. Okay, red and red is the most likely outcome. Why? Because it has the highest probability. Then you have a tree diagram without replacement. That means no replacement. This is when you say that this is a dependent event. Dependent event means the first event has affected the second event. Okay, so there are 7 flavored candies, 2 strawberry and 5 mango. 1 candy is taken and eaten. So if eat ready means 1 is 1 less, correct or not? So if originally in the box I have 7 candies, if 1 is eaten, you are left with 6. So in the first pick, it will be out of 7. But in the second pick, so just think about it as a realistic scenario. You have a box with 7 candies. You offer to somebody, somebody already eat 1. You are left with 6, right? When you offer it again to that person, it is out of 6, correct? So it is that simple logic. Okay, a lot of students get confused with this, but it's just that simple logic. There is nothing that is so complicated. All right, so strawberry and mango. So SM, just write the initials of it is fine. So 2 out of 7 is strawberry because 2 out of 7 candies. 5 out of 7 is mango. Now 1 is taken and eaten. So whatever probabilities that you have in the next pick must be out of 6 because it is 1 less. All right. So now this is also simple logic here. You're holding a tray of 7 candies. In there were 2 strawberry candies. You offer it to someone. That person takes 1 strawberry candy. How many strawberry candies left in your tray? Only 1, right? So that is the simple logic. Please don't get confused. Just think of it as a realistic scenario. You will get it. If you overthink it, you're going to confuse yourself. All right. So initially you had 7. So of course 1 less. All your probabilities now will be out of 6. So if you have eaten 1 strawberry candy, there were 2 in the box. How many left? 1. So 1 out of 6. And the mango should be 5 out of 6. Why still 5? Because there are still 5 mangoes. It was untouched because the first pick you only pick strawberry. So mango is still 5 out of 6. The other trick to the tree diagram is, this is 1 gang, right? It should total to 1. See, 2 over 7 plus 5 over 7 is 1. 7 over 7. This is 1 gang. This gang should total to 1. So 1 over 6 plus 5 over 6 is 6 over 6. Total is 1. So you're right. This gang also must total to 1. So let's go through this. So now mango. In the first pick you take mango. So you're left with 6, right? You didn't take strawberry. So strawberry still got 2. 2 out of 6. Mango, there was 5. 1 already eaten. You are left with 4 over 6. You total up, you get 6 over 6. You're pretty much on the right track. Pause and play. Try to digest it as you go along. Okay, just don't confuse yourself. Look at it as a realistic scenario that you are doing it. It's happening in front of you because it is pretty much logical. Okay, you have 2 strawberry candies. In the first pick, you already take 1. The second pick, less by 1. So if there was 2 earlier, you'll be left with 1. If the first pick, there were 5 mangoes, you already taken 1, you'll be left with 4. That's it. Simple logics. All right. Don't confuse yourself. Write down your outcomes. These are all compulsory. You get marks for all these. Write your outcomes. Write down your probability. Totally make sure you check is 42 over 42, which is 1. You're pretty much on the right track. So which is the most likely outcome? The one with the highest probability, what would it be? A mango and mango. Taking a mango candy first and getting another mango candy in the second pick is the highest probability. Okay, so here you have exercise 7.4 to complete. So right after this, please complete it. Okay, in my slides, the answers are there. If you see, the answers are here. So you can pause right here and get it done. Okay. Basically, 7.4, I've done it on a piece of paper. I'll take a photo and I will share it in the channel for today. All right. So pretty much what is happening here? There are 5 Smarties left in the box, 3 pink, 1 red, 1 blue. You decide to eat 2 of them one at a time. So don't think, oh, you decide to eat 2, you have to reduce by 2. No, it's 1 at a time. So we are back to the same concept as this. So initially there are how many? 5 candies, right? So same, first pick will have out of 5. Second will be out of 4. So you're eating 2, but 1 at a time. Here also you are eating 2, but 1 at a time. Okay, first pick, this is first pick, this is second pick. So same, you're eating 2 but 1 at a time. So same scenario. Don't go and say must reduce by 2. What? No, this is a common conception here. Two at a time, but one at a time. So it's the same concept as this. In your syllabus, you don't have deducting by two one shot. Don't have. It is always deduct by one. You will do one event by one event. Understand? Okay, so I will share the answer for this. You should be able to manage. All right, question 2. One after the first is put on the table. So when you see something like that, you know it is back to the same thing. It is dependent scenario. You must reduce by 1. All right. Okay, this one without the first marble being set. That's why I'm saying the questions are very clear. You just follow the instructions. Here they already draw the tree diagram for you. All you need to do is fill up the probabilities. All right, fill it up. Okay, try to understand it slowly. You will get it. Okay. Next one, replace. So this is independent. So if I'm replacing it back, whatever probabilities I have here, here will be exactly the same. Because it won't change. It is the same. All right. So that's about it for the for the tree diagram. Now we will have the two-way table. Two-way table is something new to you. All of you have not done it before. You have not done it in school, but it's pretty much really direct. Okay, it is either we call it the table of intersections. Why table of intersections? Basically, two-way table, we talk about basically two different outcomes. So if I'm talking about A happening, A not happening. If I'm talking about B happening, B not happening. Then what's here? A and B. What's here? A and B prime. Here is A prime and B, A prime and B prime. So this will be the total. This part is always the total. Total of A prime should total to 1. Total of B prime should total to 1. So I tell you what, this is similar to the Venn diagram question. So fill it up accordingly. Let's do one question so you will know what I'm talking about. Emma has collected information about the cats and dogs that children in her class have as pets. There are 30 people. For each people, there are 4 possible responses they could make. So it's either you have a cat or you have a dog or you have both. So that is what you call two-way table. Here I put dog, here I put cat. You have a dog, you don't have a dog. You have a cat, you don't have a cat. So we're going to fill this up together. Right here they said the total is 1, meaning the total is 1 means they want you to put the fractions. But if you don't want to put fractions, it's also fine. We can just make the total 30. Let's learn it this way first so you know what I'm talking about. Okay, 8 people have a cat and a dog. So they have both. Where do I put it? Here. So this is where 8 goes. 4 people have a cat but not a dog. So look, it's just like filling up a table, you know. It's like a jigsaw puzzle. They have a cat but not a dog, so 4 goes here. Do you get it? They have a cat but not a dog. So they have a cat but no dog. So this is where, because this is cat and no dog. Understand? So you can total write it 12. So if this is 12, this must be 18, correct? Because the total is 30. 15 people have a dog but not a cat. So have a dog but not a cat, 15 should go here. So this should be 23, correct? If this is 23, this should be 7. 3 people, they have none. So that's correct. 3 people goes here. So can you see all your totals match? So you're pretty much right. So this is just like filling up a jigsaw puzzle. So if you're supposed to give it as probability, everything over 30 lah. 8 over 30, 15 over 30. Okay, of course in the lowest form then the total will be 1 already. So make sure you put it in the lowest form accordingly when they ask you, if they ask for probabilities. So this will be also over 30, also over 30. So I'm doing this with you as we go along, right? So then the total will be 1. All right. So let's fill up with the appropriate value. So what will be inside here? Okay, in the middle here, they have a dog and they want values. They don't want probability. So just fill up the values. Inside here will be, they're both 8. Okay, so let's say this is cat and this is dog. Okay, so here will be 8. Here, they have a cat but no dog. This will be 4. Here, they have a dog but no cat. 15. Then outside is 3. Understand? So that's the way you do it. So just exercise 7.5 is here. I want you to complete it. Okay. This one is the same. In a car, there are 8 blue cars. In a car showroom, there are 8 blue cars, one of which is a hatchback. Okay. I will go through this question with you. Okay. So One of which, okay, question 1 and 2 honestly is very simple. Like here is empty. Why? Because you have the total. 484 minus all this will give you this. Then you just answer the questions. In a car showroom, there are 8 blue cars, one of which is a hatchback. 6 out of the 20 cars are hatchback. So now what you have, what are the two variables you have? Blue and hatchback. So what you must do is this. Blue, not blue. Hatchback, not hatchback. Okay, go back to the question. There are 8 blue cars. That means in total, blue must be 8. Do you see that? One of which is a hatchback. What does that tell you? That particular car is blue and it's a hatchback. So blue and a hatchback, that's 1. So 1 plus 7 should be 8. So this will be 7. So automatically you already got that value. So if this is 20, this should be 12 because you have this as 8. Understand? Okay? 6 of the 20 cars are hatchbacks. That means your total of hatchback is 6. So this is 6. So once you have these values, then you can just fill up the rest. So if this is 6, this should be 14. Okay, if this is 14, and this one we already got just now was 7, this will be 7. If this is 7, this will be 5 because this must be 12. So it's like basically doing your Sudoku, you know, or your jigsaw puzzle. It's the same thing. Okay, how many are not hatchback? That means both, they're not hatchbacks and they're not blue, would be this value, which is 7. Okay, so let's look at question 4. Same thing. In a class of 32 people, there were 8 girls who played hockey, 5 boys did not. How many played hockey? If there were 15 girls in the class. So if you take a look at this, girl, you can even put not girl. Not girl is boy, isn't it? Okay, so either you put GB or G prime, doesn't matter. Play hockey, don't play hockey. So read the question accordingly and just fill it up. It shouldn't be a problem. I'll go through this one last question with you, then I'll let you do it on your own. 32 people all together, that means my total must be 32. There were 8 girls who played hockey. That means they were girls and they played hockey, 8. Do you see that? 5 boys who did not. 5 boys who did not play hockey. That means they were boys and did not play hockey, 5. How many boys played hockey? If there were 15 girls in the class, that means my total for girls must be 15. So you already got this. This was 8, this will be 7. Then you just fill up the rest, then you should get this as 12. Okay, question 5. A and B are independent events where A is 0.8, that means the total of A is 0.8, the total of B is 0.7. So you can find this, right? Correct or not? So what is that value? Where you can fill up, you fill up first. Alright? So this will be 0.14. 0.14. What would this be? 0.2. What will this be? 0.24. Okay? This will be 0.3. That's what I'm saying. It's actually not so difficult to do it. Okay? A prime intersection B prime. What is it? 0.06. A intersection B prime. A intersection B prime, this part, 0.24. A union B. Now what is A union B? Everything inside A and B, right? So if you look at the bubble, let's go back to this bubble so you know what. A union B is all this, everything inside here. All inside here, understand? So now in this table, there is no A union B. But what you have is what's outside here. Correct or not? Now they want A union B means they want the one inside here. Correct? But it's not in the table. But what you have in the table is the one outside here. Correct? Total probability should always be 1, isn't it? So 1 minus what is outside will give you the total for inside. Correct? Alright, so 1 minus 0.06 will give you the answer, 0.94. So it is all right here. Okay, 0.94. Do you see that? Alright? So that will give you the answer. So you should be able to manage this, okay? So I will leave you to do questions 6, 7, 8, 9 and 10 on your own. It shouldn't be a problem, okay? Like here, they have given you A union B, right? So in other words, you know, basically you pretty much know A intersection B prime, what should it be? If A union B is this, A, okay, I'll just write it for you. Okay, intersection B prime must be 0.3. So I'll just fill this up for you. So A intersection B, 0.15. Total of A, they told you is 0.4. So here they've given you as 100, right? So what they want from you is 15. You times by 100, isn't it? So this will be 15. This will be 40. This will be 25. Can fill up already, isn't it? Then here also you can fill up. What is this? 0.3, which is 30. So if this is 30, this will be 55. Okay, so if that is 55, this will be 45. Correct? This will be 30. So it's just like filling up a puzzle actually, you see. You can fill up. So whenever they give you A union B, you can find this. I've already showed you from the diagram why, right? Okay, so I will leave you to complete all this. The answers are here. Okay, just pause and play as you go along. Especially question number 10, they are actually asking you for probability. So make sure you give the answer as probability. Okay, all right, so today we will complete 7.4 and 7.5. It shouldn't take you 2 hours. You should be done within the next 1 hour, 20 minutes or so. All right, so we have completed Venn diagram, list and greets. Today we have done tree diagram and two-way table. So basically this concludes chapter 7, which is sample space. So when we start chapter 8, you'll be using all these sample spaces and applying all the probability laws to it. So right now it is still very simple. As we go to chapter 8, then you will find it will become a bit more difficult. All right, okay, so if there's any questions, just ask. We will conclude the class here.